Bismillahirrahmanirrahim. We will discuss applications of parabola to engineering. In fact, we have many applications of the parabola to engineering, like the parabolic reflector and suspension bridge and arc bridge. In our problem, we have a parabolic arc in a concrete bridge as shown in the figure. It has clearance 50 feet above the water. So the clearance is 50 feet above the water. Here is the water. The clearance here 50 feet. And it spans distance of 200 feet above the water, and this means this distance from the beginning of the bridge to the end, it spans 200 feet, and this distance is 200 feet. Because of the symmetry of the parabola, so this is 100 feet from here to here, and this is 100 feet. We can see that the parabola opens down. Since the parabola opens down, why? Because people walk on the bridge, over the bridge like this. So the parabola must be opens down. Therefore, this is the second case of the parabola. Therefore, it is a parabola of the second case, which has equation on the form x squared equal 4ay. This is our suggested equation in this form. Now we need to determine a. To determine a, we need to find a point x and y lies on the parabolic curve to determine this value of a. If we assume that the center or the vertex of the parabola is the origin, so here is the y-axis and here is the x-axis. Now this point, according to this point as a vertex, this point has a coordinates 100 and minus 50, because it covers 100 from x-axis and minus 50 from y-axis. And don't forget, this point is the origin. So this point is in the fourth quadrant. This point lies in Q4 according to this coordinate system. So now we have the point 100 and minus 50 lies on the parabolic curve. This implies that 100 squared instead of x equals 4ay. We can put instead of y minus 50. Therefore, a equals 10,000 over minus 200. This equals minus 50. So a equal minus 50, smaller than 0, as we have expected, because the parabola opens down. Now the equation of the bridge is x squared equal 4 multiply A minus 50 multiply Y, so x squared equal minus 200y. This is the equation of the bridge. The second problem, we have a designer of 200 feet, diameter parabolic electromagnetic antenna like this for tracking space ropes. Want to place the focus 100 feet above the vertex. See the opposite figures. So if we need to track the space ropes, we need to locate the parabolic electromagnetic antenna like this. يعني the parabola opens up. Here the parabola opens up. So the coordinate system may be, here is the origin, here is the x-axis, and here is the y-axis. Now the parabolic antenna can track the space ropes. In this position, parabola opens up. So this is the second case also of a parabola, which suggests an equation of the form x squared equals 4ay, where a must be bigger than 0. The demand is find the equation of the parabola using the axis of symmetry of the parabola as y-axis up like we have done, and the vertex at the origin. He said that the engineer want to place the focus 100 feet above the vertex. If we want to put the focus here 100 feet above the vertex here, so this means that A equal 100, because A is the distance between the vertex and focus. So all this distance is 100. Substituting in the equation of the parabola, therefore we have the equation of the parabolic antenna, the equation of the parabolic antenna is x squared equal 4 multiply 100, 400y. The second demand, determine the depth of the parabolic reflector. The depth of parabolic reflector is this. This is the depth of the parabolic reflector, this h. To determine this value h, don't forget we have the equation of the parabola x squared equal 400y. So if we find a point on the parabolic curve satisfies this equation, we can, by knowing x we can know y, by knowing y we can know x. Now this point has coordinates 100 and hy, because he said in the problem a designer of 200 feet diameter, 200 feet diameter. So the diameter of the antenna is 200. Since the parabola is symmetric with respect to the vertical axis passes through the vertex اللي هو y axis, so this space is 100 feet and this space is also 100 feet. So this point has the coordinate 100 and h, and this point has coordinates minus 100 and h. We can use any of these 2 points to determine the unknown h, which is the parabolic reflector. So we can use this point. For example, we say that since the point 100 and h lies on the parabolic reflector, this implies that 100 square equals 400 multiply h. This implies also that h equals 10,000 over 100. We can cancel 2 zeros with 2 zeros. Finally, we have h equals 25 feet, which is the length of the parabolic reflector. Thank you very much.